Dr. Newton Campbell there in Perth with AROSE. Thanks for joining us on Australia in Space TV.
Thanks so much. It's great to be here, Chris.
Newton, I was just watching our video from Avalon as well, and you joined us in Sydney for an AI in space event. So it's great to have you back. And it's on the back of Trailblazer being announced. The AROSE Consortium has been shortlisted down to 2. So congratulations, and you're the Director of Space Program. So this is pretty much why you came to Australia, and you're working with AROSE, correct?
I mean, it's a big part of the reason. There's such a great bustling space industry and space community here, and I love being a part of this. But yes, this is the flagship mission that was very much a draw to me coming down here.
So what's your sort of role? Where are you going to take it from now? Maybe just a bit of an overview on Trailblazer.
Sure.
Most of the industry will know, but there's going to be a lot of tech transfer here. So it is a pretty big deal, right?
It is. Oh, it's a huge deal. I mean, the Trailblazer program. So let's start from the top. It's supported by the Moon to Mars initiative. And the idea is to have Australia play a major role in delivering foundation services on the moon. The program itself is sponsored by the Australian Space Agency. They've selected us as one of 2 consortia to get to preliminary design review, effectively where we both make designs and start to build prototypes that are going to be used for a rover that's actually going to move lunar dirt, what we call regolith, on the moon. The idea is to build a lunar rover no earlier than 2026 when this thing launches at a scale of 20 kilograms. And it's going to be built to scoop that regolith and deliver it to a NASA in situ resources utilization facility. And that's a very specific term that I'm using there, in situ resource utilization. In the space sector, we call it ISRU. The idea there is there's chemical composition and molecular composition within the lunar surface that we actually want to do scientific experimentation on. And we want to be able to analyze that in the environment, in situ, to identify whether or not we can use it for resources. What are some of the compounds that it's made out of? There was some actually pretty big news this week revealing that effectively there's a much more significant amounts of water in the lunar surface, in the lunar surface regolith than we thought. So those are the kinds of experiments that we're going to be supporting NASA by building these scooping mechanisms. Those are the kind of studies that we want to pull from this.
And the rover won't be doing the analysis itself. It's just to go and collect and bring it back to a central lab on, as you say, in situ.
Correct. Yeah. The process of building a rover that can actually do that collection is hard enough. Let me put it that way. Effectively, lunar regolith, I mean, it can be some pretty nasty stuff, right? So the regolith itself, it can be sharp. It's not like digging up, normal dirt here on Earth. And there's all sorts of problems that we have to tease out in order to actually get something like this working. For instance, lunar surface is subject to extreme temperatures. It can range from negative 173 Celsius to, and that's during the lunar night, to 127 degrees Celsius during the lunar day. So you have to design robots that can deal with those kinds of issues. The regolith itself is also composed of an electrically charged abrasive silica. And since the moon has no atmospheric or liquid erosion properties, it's much sharper than soil particulates here on Earth. And we're just not used to dealing with that, even, in what we deal with in the Pilbara. But part of the reason AROSE was formed, our organization, the Australian Remote Operations for Space and Earth organization, was to take some of those capabilities from the resources communities. Groups like Rio Tinto, groups like Woodside, they're all contributors to AROSE. We want to be able to take some of those capabilities and form them into space grade capabilities that can do this kind of work. It's really about leveraging that Australian expertise and some of the technology, but more so the expertise in thinking about these problems in the space community. That's really why the AROSE Consortium was formed.
And
And
we
the
have had,
benefit, go ahead.
so don't go.
No, well, I was going to say the benefit to having those resources, companies do that, mining companies do that, because I've never really worked with mining companies or anything like that, is that by making space grade capabilities, it forces those folks to think about, well, how can I decarbonize this technology that I'm using in the Pilbara? How do I electrify certain technologies that are currently being run on fossil fuels? How do I miniaturize those technologies so that I can do that work in space? Trailblazer, which is an apt name for this program, is blazing the trail of them thinking about that and having to do that on a specific mission. And it's going to create pipelines, it's going to create, just a way of thinking about certain problems within those spaces that hopefully will help with decarbonization, electrification, and mining in mining in the future.
Well, we have had sessions on robotics in space. It's a very challenging environment, as you pointed out, things like radiation and all sorts of other things. How much new tech is going to be needed here? Because again, we've had a drone sort of operate on Mars as well, so it can be done, and obviously the rover has been active. Is there anything new here, or is it sort of the building something just from an Australian capability, but the technology and the design will be relatively known?
Well, so yes and no, right? There will be transfer of technologies, but everything you're building is almost entirely new because again, you have to make these technologies space grade. What does that mean? That means they have to withstand extreme temperature variations, right? Not just built for the hot, not just built for the cold, but built to deal with both of those things. So new forms of shielding and that sort of thing. In terms of the sensors that need to go on board, they need to be able to detect those variational shifts and potentially modify the actual robot itself, as the temperatures are swinging. When it's actually doing some of the digging, again, we have to think of new ways and potentially leverage new materials or materials we may have had insights from, again, working up in the Pilbara and in the resources regions up in the Western Australia and the Northern Territories to deal with electrically charged dirt that you're moving around and sharp dirt that you're moving around. So it's a good blend of testing out technologies that we already have. We already have automated hauling technologies through groups like First Mode, which are one of the folks that are going to be operating on this. We already have automated trains, and technologies for loading up those trains through Rio Tinto. But the idea is to take those technologies and not just augment them, but effectively you need to take the expertise that went on behind those technologies and yes, create some things that are new, but borrow algorithms, borrow sensing capabilities, borrow, again, that expertise to actually deal with this mission.
And I was going to say, you're not just simply going to shrink down a tip truck
No.
down to 20 kilos. I suppose that's a point there is the weight, the 20 kilo limit.
Yeah.
Is that plenty or is that pretty tight in terms of that weight and designing this?
That's what NASA is going to allow us to ride on their rocket in 2020.
Have they just come up? Obviously, the weight is everything in space, but have they just come up with that? I don't know how heavy the Mars rover is, for example, but it's not 20 kilos. It's pretty much heavier than that.
Yeah, it's bigger. Really, again, this is about delivering it to the ISRU facility to CLIPS, on the NASA side, and it's really about sampling, right? This isn't a massive one that we want to take to actually haul loads and loads of regolith, which again we only have to do at about a sixth of the capacity that we can do it here. And up north, we're dealing in tons and tons, yeah. Right? With the 20 kilogram rover here is to collect, small amounts of lunar regolith so that we can actually sample and run science experimentation, because the science experimentation facility that NASA is going to have for this isn't going to be massive either, right? It's only going to be able to take in so many samples that will provide. And so, 20 kilograms should be more than enough. Also, for an effort that's moving this quickly, right? We're only talking about a 5-year window here,
Yeah.
and probably less at this point. 4.5 up to 5 years. And so, for something of that size, for an effort of that length, you'll want to do something that's relatively small and manageable, as opposed to dealing with issues in terms of load bearing and weight and balance that could come with something much larger on the moon.
And how long is the mission in terms of how many missions does the rover have to do? Does that affect how it's designed as well?
So yeah, the rover is only going to, it's only planned for the 2026 mission. So once it launches, once it actually does its collection, it'll do a series of back and forth collections to the same facility. But that's really it, right?
Is that how many collections it makes? Is that defined?
Not as of right now. I think that's going to come after the preliminary design review. So they'll actually start identifying some of those additional capabilities. Right now, the only requirement that we know of is to just do the collection, and to prove out the capability. But going forward, it will be able to, and it will be built to do multiple collections.
Yeah. Well, things like contamination and the like, new samples would be needed.
Exactly.
I suppose one of the other areas, and with your antecedents, you've got a lot of experience in AI and the like. I know this is a competitive process too, but how much AI will be involved or applied within the design phase of this?
Mm-hmm.
Is it from a design team going, look, forget anything's been created in the past, and let's go with an absolute white sheet of paper and start again, and you may well apply AI in terms of the design. How much sort of advanced tech are you going to be applying in this versus the human knowledge that you've got there as well?
So there will be a significant amount of advanced tech, especially as we're thinking about remote operations components, right? This is going to be a semi-autonomous rover. And what that means is when you're doing command and control here on Earth, you can usually rely on a fairly real-time amount of delay when it comes to commanding and controlling the robot. But when you're talking about the moon, you could be talking about several seconds delay depending on a number of factors, right? So number of interference factors, you could be talking about radiation, all of those things. And so you have to, even in that circumstance, from an operational standpoint, introduce artificial intelligence capabilities that will effectively help guide the robot in times of that latency to continue operation and continue to make sure that it's maintaining its own safety as well as respect to the environment. From the design standpoint, I can't go too much into design. However, there have been fairly significant advances in testing out designs for rovers as well as for spacecraft that I've done, particularly mostly on the NASA side, but being able to run through massive numbers of scenarios for testing, doing work like concurrent design, which are capabilities that we have within the consortium. So concurrent design, the idea is to have multiple people designing different aspects of something at once and running simulations over and over again. So some of those capabilities get not just used, but advanced when you have to do something like this, which is once again the benefit of Australia investing in something like this in the first place. It's to be able to it's to be able to come up with new innovations in the way that we create and design robotics in the first place.
Well, maybe talk us through some of the partners in this, and then that brought me to what skill sets are at the table as well.
Sure.
And how many? I mean, I imagine you'd have to create a core team. I'm thinking, but the amount of people with the partners you mentioned, Rio Tinto and Woodside, you've potentially got thousands of people available for you. Can you talk us through the team design, the structure, and the partners?
Sure. Sure. So the team is comprised primarily and leading the pack from the technical standpoint is Fugro. It was once a Dutch company, but they operate. I mean, they are still technically a Dutch company, but they operate significantly here in Australia, doing marine asset integrity management. They have recently built a facility here in Perth called the Space Automation, AI, and Robotics Control Complex. It's SPARC. It sits in the middle of Perth, in the middle of downtown Perth, and it is one of the most advanced remote operations facilities that I've ever seen. They have taken lessons learned from folks all over the world who have done remote operations from deep sea all the way into space. And in fact, Dawn McIntosh, who is also ex-NASA like myself, she's actually the one that is she's the program lead for this project. So for the Trailblazer project. And she's taking a lot of those lessons learned from NASA, what went right, what went wrong in different missions, and applying them in this space. We also have working with them is Nova Systems Australia. They are largely a consulting company with an immense amount of systems engineering capability. So their folks work with defense, work with space, work in all sorts of different sectors, and really focus on introducing and applying a systems engineering approach to the construction of multiple capabilities or the operation of multiple capabilities. So they'll be playing a lead role in this as well. And then finally, we have First Mode, which is a company that recently merged with Anglo American. They started out with a bunch of folks from the NASA Jet Propulsion Laboratory, and they have significant experience designing automated hydrogen-powered trucks that are actively working up north right now as well. They're hauling tons and tons of material using clean energy and and basically creating autonomous systems capabilities for actually building that out. So that's sort of the core team. And then, like I talked about, as a part of our consortium, we have other groups that we're planning to bring in, particularly in like stage 2 phases and things like that, like Rio, like Woodside, as well as other significant companies here in Australia. So that's sort of the core makeup of the team, and then AROSE sits on top of that and does a lot of the facilitation. Right? I personally will be going through and vetting and serving as sort of verification and validation, as well as someone who is just a trusted advisor for artificial intelligence on the project. And Dawn is really leading the way on the project. So there's sort of a good separation of tasks there.
Well, we interviewed Dawn at Avalon as well, and we'll try to reach out to her, but she's going to be pretty busy. So what's the time frame here? What's the next deliverable? I understand it's 15 months. It's a 5-year project.
Yeah.
So where will you be in 15 months? What's the expectation?
So the expectation is to have, a set of prototypes that prove out any capabilities that are significant to our design, and to have the design ready to go. So when you're thinking about what we call PDR in the space community, that's preliminary design review. The idea behind that is you have a formal inspection of a high-level architectural design of an automated system and its software. And that gets conducted to achieve the confidence that the design satisfies the functional and non-functional requirements that were set forth usually by, I'm so used to saying by NASA, by ASA in this case, which is awesome to say, right? Again, if you told me that we'd be here, prior to 2017, I don't know if I would have believed you, but since Australia really kicked off its space agency, they've just been doing amazing things. So yeah, the preliminary design review is going to be conducted by the Australian Space Agency, and the whole idea is to have that formal inspection of the design such that they have the confidence that it meets the requirements that they've set out, those requirements to be able to have remote operations of a rover, the requirements for it to be able to carry lunar regolith, weight, size, sustain parts of the environment, all of these requirements that are absolutely necessary. They gather some of the best scientists and engineers in Australia to basically assess that design and gain that confidence. So that's really what that's really the focus of that. Both Don and myself have had to prepare for a PDR in the past, which is actually really great. It's a good combination of diving enough into the technical to do the prototyping and to do the architectural design and even run some experiments to say, well, can this actually handle this weight? Can this actually balance in this way? Can this, can we operate at these time scales? And then match that up against these requirements that are human needs, right? That were set up by humans to say, this is our mission. This is the operational thing that we want to do. This is where that gets confirmed. And I'm really looking forward to, to doing that process here with the Australian Space Agency. Again, it's amazing to even say that.
Well, and as you say, yourself and Dawn, ex-NASA, you've just had Bill Nelson and Pam Melroy in Australia, literally just I think last week, if time's not going that fast for me. What indicator does that have for you as well, given, as you say, 2017, you wouldn't have imagined yourself here. But here you are, and literally we've got NASA administrators speaking to the Australian public and making these kind of announcements. It is a new form of business for NASA.
Yeah, the thing about this, and really the key difference between Apollo and NASA's Artemis mission, for which this is all sort of, I won't say it's a part of NASA's Artemis mission, it's a part of the global Artemis Accords, right? So NASA has established these accords with 22 different countries, because unlike Apollo, where sure we did have a little bit of international help, we're not going alone. Right. And that's the entire idea behind this. The idea behind the Artemis endeavor, these accords, this was something that had been planned for nearly a little over a decade by NASA, was to build this infrastructure around the moon so everyone can go. And that is really the spirit overall of the Artemis mission. Everyone is going. It's why they're putting a woman and person of color on the moon first, because they want to show that everyone is going. It's why they've gotten 22 countries on board to contribute to this, so that everyone can go. And you really see that in the passion that both Bill Nelson and Pamela Melroy, who used to work down here and was kind of fundamental to starting AROSE, you really see that in the passion that they have when they talk about this. Because at the end of the day, they understand that space is a global endeavor, and that this is something that's about more than just the United States at the end of the day. But like I said, when I came down here, a rising tide floats all boats. It's beneficial for NASA to have so many allies that are focused in the space community and that we can work together with in space. It grows the space community overall, which at the end of the day is what we want to do, to heighten discovery, to capture the imagination of people around the world. From the earliest days of human spaceflight to the breathtaking images from deep space probes, the mysteries of the cosmos have inspired generations of scientists, engineers, and explorers to push those boundaries of what we know and what we can achieve. And so having Australia take part in this journey, having those little kids in Australian classrooms who will likely one day be going to Mars or the moon, having them take part in this journey is significant to the work that we do back at NASA as well.
Wonderful. Well, hopefully the design includes a little Australian flag on there somewhere.
Of course.
But look, keep up the great work. We will stay in touch with you and continue to obviously monitor the progress and how this goes. And as you say, the Artemis missions and the Accord, there's so much yet to come, really. It's an exciting time. And it's great to have AROSE and Western Australia involved, and they're at the forefront as well. So shout out to Dawn and also yourself, Dr. Newton Campbell Jr., Director of Space Programs for AROSE, the Australian Remote Operations in Space and Earth there in Perth. Thank you very much for joining us on Australia in Space TV.
Thanks so much, Chris. Thank you for always getting the message out about space. This is one of the most important parts of space work. So thank you very much for everything you guys do.
Easy to do. Thanks.
Cheers.